Discuss the following challenge: assign cookies. It was the daily challenge for January 1st. Assume you're an awesome parent and want to give your children some cookies, but you should give each child at most one cookie. Each child I has a grid factor gi, which is the minimum size of a cookie that the child will be content with, and each cookie j has a size sj. If sj more than gi, we can assign the cookie j to the child I, and the child I will be content. Your goal is to maximize the number of your content children and output the maximum number. Okay, let's consider the example 1. You have 3 children with grid factor 1 to 3, and we have 2 cookies with values 1 and 1. For the first child, whose grid factor of 1, we can give our first cookie. And the first child will be content, but let's move on. For the second child, whose grid factor of 2, there is no cookie that matches its value or more. For example, we cannot give our second cookie to the second child because the second child won't be content. And as you can see, there are no more cookies, and the output will be 1 because there is only one child who is content. The idea to solve this challenge is pretty simple. We just need to iterate towards the end of both arrays and compare at each index. For example, if for the first child whose grid factor is 1, we need to find some cookie that whose value more than this value. For example, for the first cookie has more or equal to this value, and that's why the first child will be content, and we need to iterate towards the end of both arrays. The first child is content, and next we have our second child whose grid factor is 2, and then the second cookie has value 4, and actually this cookie may be given to any of these children, and any of these children will be content because its value matches both of their grid factors, and that's why our second child will be content. As we reach the end of this array, there are no more cookies. There are no more cookies here, and therefore we cannot make any other child content, and the output will be 2. Okay, if we reach the end of any of these arrays, we just need to return the result, because if we reach the end of this array and let's say that there were some more cookies, we cannot give extra cookies to these children because these children are already content and there are no more children. That's why we need to return the result. Okay, let's code this problem. All we need to do is just to sort both arrays. Okay, cookies sort, and I need counters to count the indices. For this, I need to have grid index 0, var cookie index also 0, and the number of content children. Initially, the value will be 0 because in the beginning we cannot say how many content children will be happy. That's why let's go on. While true, if we reach the end of any of these arrays, we will return the result. If grid index is equal to grid size, or cookie index is equal to cookie size, then return the result, return content children. And the main condition of this challenge, if cookie index more than grid index, then this child is content. That's why we just increment our variable and increment the indices as well. cookie index ++ and continue. However, if this condition is not met, then we need to iterate towards the next cookie. Okay, actually this is a solution to this challenge. Okay, let's run, and the output must be 1. This is because the first child is met with the first cookie, but the second child has a grid factor of 2, and we don't have any cookie that's value more than 2. That's why the result will be 1. We cannot give the second cookie to the second child or the third child because these children won't be counted with the value of 1. Okay, let's copy the result, the code, and submit it here. Okay, let's go and check the results. Submit. Let's wait a bit. As you can see, the runtime beats 96% of users with Kotlin. It means that the algorithm was pretty efficient, and the complexity of the algorithm is, runtime complexity is O(n) log n. This time is spent on sorting both arrays, and to find out the result, we just need to iterate only once towards the end, till the end of any of these arrays. That's why for iterating, we will spend O(n) time. However, the overall time complexity will be O(n) log n because it's far greater, and as we if you study calculus, at university, you usually know because all these concepts came from limits, and time complexity is O(n) log n for this algorithm, for this challenge. This was the end of this video. Okay, thank you for watching.